new stream today to demonstrate some experimentation with rotary encoders using a Raspberry Pi Pico and running MicroPython. So what I've been doing is that I've set up a little breakout board here with a rotary encoder. So the rotary encoder is this part here, and those parts tend to be not very breadboard friendly, so I just wired it up on a proto board and made some connections here, exposed that to some breakers. There is also a stick here that will be for a future video. For the moment, we are focused just on the rotary encoder. So I also set up here on the breadboard a minimalist circuit that has a couple of capacitors, 4 resistors, and that aims at reducing, rebounds from the rotary encoder. So it just eliminates some noise that often happens with these components, and this is straight from the datasheet, so very easy to reproduce. And on the other hand, there is a lot of wires here, but I'm only using 2 of those. Well, 3 if you count. Well, 4 if you count ground and VCC. But anyway, yeah. So I wired all the ports on the Raspberry Pi Pico, which is here, and this is just a one-time thing that I did on this Pico, so that I have all the GPIOs here on the breadboard that correspond to the numbers. So I don't have to think about what is connected where. I can just look at the numbers on the breadboard, and I know that's GPIO number, whatever I read there. So here, the outputs for the rotary encoder. So a rotary encoder has basically 2 outputs. And here they are on pins 20 and 21. And yeah, a rotary encoder has 2 inputs, and you know which direction it's going by looking at which one goes first. So they will both switch when you rotate the encoder. But if you go left, the first one will go first, the second one will go second, and if you go the other way, that's reversed. And actually, let's switch to the logic analyzer here, and I want to show you actually what this looks like. So let's start recording, and at the same time I'm going to rotate the rotary encoder. We should see it. Oh wait, no, because I have the pull-up from the Pi Pico here, so I would have to turn it off first. Let me just unplug the Pico from those pins for now. I'll plug that back in when I'm done. But yeah, okay, so that should work. No, it doesn't. Oh, I didn't start. I timed out. Okay, so nothing's going here. That worked earlier. I have a great demo effect here. Logic analyzer is connected. I did have a timeout here. Let's try again. Oh, wait. Well, this is from a previous session. I can actually show you here what happened before. And I will also connect back those pins. Yeah, so here you can see 2 cases. So in one case, we are going one direction, and you can see that the first pin went down first and then the second. And if we go to the reverse order, that's in reverse. This one goes first, the second goes first, and the first goes second. And this is what creates the alternate directions. So we have to reproduce that in software. And the way we do that is by going into code. And okay, so I connected my 2 pins to my encoder A, encoder B to pins 20 and 21. And then I read the initial value of A. And then, well, the important part here is that I'm catching any change in state. So whenever A and B go up or down, I go to this method here, this function here, and this function here is reading the new values for A and B. If A and B are both set, then we look at which one was was the first to go. And in that case, we go in one direction. In the other case, we go in the other direction. And otherwise, we just memorize. So what happens is that, so if A goes first, then we are going to set previous A to true. And then when B goes second, then we'll increment the counter. And if B goes first, previous A will never be set. And that goes in reverse. So let's run this. So if we run this, in the console on the bottom, you can see that the values are actually being printed. And if I go in one direction, then it's incremented. If I go to the other direction, it's decremented. So this is exactly what we want. We want each rotation to change the counter. All right, well, that's pretty much it. And yeah, I'll publish the code on GitHub, and I will point to it from the description. That's it for this video. I hope it was kind of clear. For me, it really implementing this really clarified how the rotary encoders work and how to code for them. All right, bye.